one of the things we don't do is shaping per app, but we allow an individual app to tag different sockets or one socket, retag it multiple times, and then read out its stats. That doesn't need to change any of the rules. So it just uses the existing rules for tracking. Internally, XT_tag_UID, as soon as it sees an SKB, says, hey, SKB, what socket are you tied to? Hey, socket, what's your FIL_P? Who's the owner? And it stores it against that. If there's no FIL_P associated with it, or there's no SK associated with the SKB, it says, OK, unsolicited packet. Oh, it also uses the connection tracker. So if it's an ongoing communication, it can find actually the owner to its destination. If it's unsolicited and it can't find it, it'll just say, hey, this is a packet that belongs to the system, and it needs to count it, even if there's no listener, because the carrier is still going to bill you for unsolicited IP traffic. And so that covers kind of the changes that we have so far. Any other questions?
Why do you use ProGFS?
True. So 2635, I look around what's available in netfilter, and I look at how people talk to the other netfilter modules that are there, and it's like, OK, seems like a way to go. If we needed to, we could switch to something else. It was like the minimal interface for a human to be able to debug, and it was sufficient, and we could handle it from the framework, the Android framework. But I'm willing to switch to anything else, IOCTLs with custom commands, sysfs if needed. Okay. So the libnetlink that's in the Android stack came after this. So we did look at the amount of work. OK, how much effort does it take to get netlink up and running? Started looking into how IP tables does it itself, and said, holy crap, I need to pull all this in. And then when I started talking to the AOSP guys, and it's like, GPL, wrong version. But yes, now that we have a libnl2, I can go back and revisit it and possibly pick netlink. I'm open to that. It seemed decent.
I'm against libnl, but that's a different story. We would do this by ourselves. Just strictly speaking from the kernel interface, netlink is an easier way to get this out, especially asynchronous, so we don't actually have to start polling this one. If you really don't have, what we'd like to see is something you can just update, so in X amount of time, please, X amount of packets, just tell us, let's give us an update that you have packets you just consumed. Because we actually tracking some of this stuff directly from RTNL. Before the device goes away, we actually write them to disk. So we actually have the basic stats from the device and then know the maximum they're going to get from this one. And feeding this one in on a similar level would be nicely matched together if we can get this over netlink and don't have then start polling, oh, hold on, what you actually consumed there.
Don't forget, the devices lie about their stats. Some of the devices that we have, they actually count in their stats traffic that they send up to user space, but it's controlled sideband traffic. So you end up being off by like 5 to 10%.
Oh, I would love to use this completely and just don't rely on the device. But there's some of the stuff we have to do. My other question that actually is a little more important. So you say you're going to do this basically on UIDs and UIDs only.
UIDs and tags. The socket contains two sets of information. One is the UID, and it defaults to the owner of the socket. But the download manager can say a specific socket now belongs to a different UID. And it can associate a tag with it that says, oh, by the way, this traffic for this UID came from the download manager. So when you look at the statistics, you can say, oh, I see this application's been using this much data. But you look at a tag and you say, oh, this is the tag that the download manager set.
Fair enough. What I was hinting in is like, can we get this also with C groups? So we can do this per C group?
So I looked a little bit in C groups, and it didn't seem convenient enough to be able to allow any kind of app to be able to use it lightly. From my understanding, it was that to be able to start manipulating the C groups and getting those type of counters specifically for an app, it would require the app to either talk to some C group controller and say, oh, I need you to do this on my behalf, go and mess around with my C groups, I need specific stats, I need a specific network device, set it all up for me. With this solution, the app directly itself, if it's native, it doesn't even need to talk to some manager that's in Android. It's, hey, tag my socket. And QTag UID will say, wait, do you actually own this FD? Do you own this socket? Okay, fine, go ahead.
Fair enough for Android, but on the desktop, where systemd stuffs you in a C group anyways, so you would be confined just from the start. That's where we are coming from. We're actually, okay, the application is in the C group. Systemd has enforced it in it, so it is right there. That would make it, we don't have to deal with any UIDs to whatever's in that C group. That's what the app has done and what process it spawned and whatever.
Yeah, so we don't have a C group per app.
How much effort would it be in theory? So assume the app gets put in a C group, just from the kernel side, how much would it take to actually change something like that?
If an app is already in its own C group, that means it gets its own network interface with its own stats. You can't trust the devices. Even Bridge is broken. The RX and TX don't count the headers in the right way. Sometimes it adds them and sometimes it doesn't.
We want to do this based on sockets. So assume the systemd had put the app in a C group, that's all there, and what socket it opened and what it consumed over that socket.
Does it do the socket consumption over protocols? We need to detect UDP, TCP, and IP.
I'm going through a different way. The app just opens X amount of sockets on whatever interface they're going to have access to.
Yeah.
And the kernel knows that this app is in a C group, so can we just automatically tag these and track them and then get the stats on the app in that C group?
Potentially. Right now, there's no need to tag a socket. The default is it's automatically assigned to the owner of it. But yeah, we could potentially go down the C group part, but it would require putting an app in each individual C group. And then how would delegation work in this case? You're the download manager, you're in your C group, and now you've got a socket that actually doesn't really belong to you. It needs to belong to somebody else.
That's definitely something that needs to be figured out. Therefore, that you could, as you guys, what I understand, you guys using extra tags for this one.
Yes, we use extra tags for this one.
Where the download manager then puts an extra tag on there, which on the desktop side we could potentially do as well, since most of things goes over dbus, so you know the owner and you can, the download manager or whatever app you want to do, or if you do something on behalf of something else, you can just tag it, but the original C group would be still in place at that point. So what we are seeing from some other sides, the C group part is way more flexible, and we don't have the strict UID separation like you have within Android. Every app is their own UID, we just don't have this, and in some OS sites, we are never getting there. And since I know we need these things, I would actually like to get into a solution that is upstream, that we can use, we get the stats out properly, and we can just share this. That's where I want to really go, because we're doing exactly, well, not exactly, but we're doing really similar things, and Daniel probably can give some comments on this one as well, to actually get per application statistics out of the system, and it's really painful.
Yeah, we do it for Conman, and we're using NF Act and IP table rules, and yeah, we feel the pain already. So it seems like it's not the right thing to do, right, going that direction. And I looked also on your work, and well, it looks good, but we have an additional requirement. We want also to do routing, so we have more than one interface up. So we want to also enforce which route it has to take. So, yeah.
Any other?
Do you actually have upstream already, or is this just?
It's Android AOSP. One of the reasons it's kept so compact is in case it never got upstreamed, it made my life easier to maintain. Unlike UID stats that's got hooks in the TCP stack, this guy has got hooks nowhere. It's completely independent. No. Linaro guys sent it to.
So we are the NetDev guys right here. So we can tell you that for a low amount of traffic, NFQ is the way to go, because you can intercept all packets in Network Manager and decide whatever you want to do. It's a user policy, all this stuff. And all the infrastructure is there already. So, and you don't have to worry to upstream anything. It's there. Yeah. Yeah. Why not? It's a, I mean, how many packets you receive on this device? It's
actually, quite a lot. And if you like,
so what?
No, this is expensive.
No, absolutely not. You receive the packets. The cost is waking up your device. Spending 100 cycles to process the packet is not. Face it. NFQ is the way to go for this low amount of traffic. Up to 10,000 packets per second, it's fine. Because it seems to me that you have a lot of stuff. For example, the XT idle time thing, it's a packet scheduler issue. It's not a netfilter issue. You need some kind of packet scheduler to solve this issue. It's not an IP table stuff.
The XT idle, it's only used to be able to see when the last packet went out and if we've reached a certain delay.
Sorry, I don't really hear you.
The XT idle timer,
yeah.
it's not used as really as a scheduler. It's just to be able to see when an interface has slept long enough. And we can then infer that it went into its low power state. So what are you doing with the
packet? You drop it?
No. We just look at it fly by and we say, oh, we saw a packet on the cell interface.
Yeah.
And we reset the counter. And if 8 seconds elapse, then we get a notification in user space that says, hey, this interface has been idle for 8 seconds. There's a high likelihood it went into low power mode. Try not to talk to it. And if a packet comes in, if a packet comes in from the cell tower, it's going to wake up the interface, and then we'll get another notification, and it then tells the framework, okay, if you need to send messages, you need to do tickles or pushes or whatever, go ahead, do it now. You've got 8 seconds before the interface goes back to idle. That's the only reason we use it. We don't have traffic shaping built
on top of it. So you intercept incoming traffic or outgoing traffic?
Both, incoming and outgoing. And all it does, it just resets the timer. We don't look at the packet itself. We just know that the interface has been given or has received the packet. That's what the XT idle timer is there for.
Okay.
Sorry? Oh, yeah.
So my point is, using NFQ, you solve all this problem because all packets are in userland, so you do whatever you want.
No, but we don't need them to be in userland. For something like the XT idle timer, there's no need to copy a packet up.
You don't copy the packet. NFQ don't copy it. It's a zero copy path.
Okay.
You only copy the headers. That's it.
How do you deal with IPv6? The options are at the end. So if you look at what the connection tracker does, you need to walk your IPv6 headers. So you're going to need a lot of data to be able to handle IPv6 packets.
It's done automatically. It's the flow dissector thing. It's generic. You don't have to care about it.
So in some cases, like some of the protocols, we just don't care about introspection. But now, because of the way, if we want to have the generic method that you're saying send all the packets to userland, you'd always have to send all the data up. And then in userland determine that, oh, by the way, we didn't need to look at the data because the protocol that's used inside the packet, I don't care for what's later on.
So what? So you are adding in a kernel all this stuff?
So what, copying stuff up to user space just to be able to realize, oh, we actually didn't need it. We could have figured it out by looking at 5 bytes at the kernel level. It's waking up all of user space and waking up everybody just to be able to realize that only...
NFQ gives all the metadata you want. Just ask to fill the metadata you want.